Is a technique for installing underground pipe without trenching. Powerful hydraulic jacks are used to push specially designed pipes through the ground behind a remote-controlled tunneling shield called a microtunnel machine. Simultaneously, excavation takes place at the front of the machine, and the excavated materials are pumped to the surface by a circulating slurry system. Microtunneling is distinguished from other tunneling techniques by four very important factors. Microtunneling is a remote-controlled operation, reducing manpower requirements and increasing job site safety. Earth pressures at the tunnel face are counterbalanced by the machine, virtually eliminating ground movements. When groundwater is present, hydrostatic pressures are counterbalanced by the tunneling machine without dewatering. And microtunnel machines can be designed to perform in the widest possible range of soil conditions with the same cutter head. Microtunneling systems permit tunneling through almost any ground, while providing maximum security against ground movements without the employment of costly ground stabilization or dewatering techniques. The end result is a flexible, hardy, watertight finished pipeline with an absolute minimum of surface disruption. On one end, a drive shaft, and on the other, a reception shaft. The drive shaft marks the beginning of the drive. The drive shaft may be circular, oval, square, or rectangular, but it must be long enough to accommodate the tunneling equipment, specifically the combined length of the thrust wall, hydraulic jacking system, microtunnel machine or pipe, whichever is longer, and entrance ring. The reception shaft, on the other hand, need only be large enough to accommodate removal of the microtunnel machine. The microtunneling equipment includes the operation cabin and remote control board, the jacking and lubrication systems, the slurry system, as well as ancillary equipment such as cranes, generators, and trucks. Then the microtunnel machine, the real workhorse of the microtunneling process, is lowered into the drive shaft and onto the guide rails. Microtunnel machine is thrust forward by the hydraulic jacks, first passing through the entrance ring, then tunneling through the ground on its journey to the reception shaft. Powered by electric motors, the rotating cutter head cuts through the earth. Excavated material is crushed in the head of the machine when necessary and passes into a slurry chamber, where it is mixed with slurry and transported to the surface via slurry pipes. During excavation, a sophisticated earth pressure counterbalancing system is employed. By maintaining a consistent counterbalance pressure on the tunnel face, always between the active and passive earth pressures, ground movements are virtually eliminated. The alignment of the machine and pipe is controlled using a laser-guided steering system. A laser beam originating from a laser at the rear of the drive shaft and set to the required line and grade is projected onto a target mounted inside the microtunnel machine. An image of the target is captured by a TV camera and relayed to a monitor in the remote control board at the surface. The operator can activate hydraulic steering jacks inside the microtunnel machine as necessary to articulate the front section of the cutter head and alter the attitude of the microtunnel machine. Accuracies of plus or minus 1 inch in line and grade are typically achieved over an entire drive. Jacking pipe consists of a female end fitted with a collar and a thin ring of fiberboard to act as a packer, and a male spigoted end fitted with a rubber seal. When joined together, a durable, watertight seal is formed. The outside surface of the pipeline is smooth, minimizing friction as its jacking system is located at the rear of the drive shaft. After a section of pipe is placed on the guide rails, the jacks are slowly extended, powered by an hydraulic power pack on the surface. The force of the main jacks and the speed at which they extend is carefully synchronized with the excavation rate of the microtunnel machine. Thrust ring and pipe ring adapter ensure that uniform thrust is transferred from the jacks to the pipe. As the length of the drive increases, so does the total friction produced between the pipe and the earth, thus demanding a greater jacking force. To reduce this friction, a clay-based or polymer lubricant mixed in a lubricant mixer on the surface is injected into the annulus between the pipe and the surrounding earth. Lubricant is always introduced immediately behind the microtunnel machine through a lubrication port in the machine. For larger machines and longer drives, lubrication ports are also provided at regular intervals through the wall of the jacking pipe to provide continuous lubrication around the pipe. This technique results in a considerable reduction in friction. Thus, the required jacking force is reduced, and longer jacking lengths are achievable. After the drive, the microtunnel machine and equipment are removed, manholes are built, and the shafts are backfilled.